In this video, we will learn about the alternating series test. First, an alternating series is just a series in which the terms alternate between negative and positive. So here are three examples of what that might look like. First one's like the harmonic series, except it's alternating positive, negative, positive, negative. And this is the way you'd write it in sigma notation or summation notation. So notice it's got -1 in parentheses raised to n plus 1. And then we have another alternating series here, same thing, powers of 2, so this is 2 to the -1, 2 to the 0, 2 to the positive 1, 2 to the 0, 2 to the -1, to the -2, to the -3, etc. So this is in summation notation, or this is the general term here, and we have -1 raised to the n power. And then in the last one, we just have n, but it's alternating because we have positive, negative, positive, negative. So all three of these, what makes this an alternating series is that we have -1 raised to some power, either n or n plus 1. It's raised to the n power if we want the first term negative, and it's raised to the n plus 1 power if we want the second term negative. This is what a general alternating series looks like, which is what we looked at on the last slide. We have -1 raised to some power. It goes from 1 to infinity, and then an is the term, or the general term. So an alternating series converges if three things are true, so all three of these have to be true. Each a sub n is positive, so this part has to always be positive. It might get multiplied by a -1, but it starts off positive. The next thing is that the series has to be decreasing, so each term, like as we go up 1, so we start with an and we go to an plus 1, that has to be less than or equal to an. So it doesn't have to be strictly decreasing, but it does have to be decreasing. And if we take the limit of an as n goes to infinity, it should be equal to 0. So if all three of these things are true, then an alternating series converges. If one of them is false, it does not converge. And we can actually say that it diverges. So it's not just that it's inconclusive if one of these isn't true. This is an only if as well as an if. They all have to be true for it to converge, and if any one of them is not true, then it diverges. So here's an example of what the graph of an alternating series might look like. This one converges. So first term, second term, third, fourth, fifth, sixth, seventh, eighth, etc. And they keep getting smaller and smaller, closer to the x-axis. So we can see like A1, the magnitude, this here, is bigger than this. So for each term, they're getting closer and closer to the axis. So that means it's decreasing. The limit as we approach infinity is 0. So this is a converging alternating series. Here is an example of what this might look like. So determine if this series converges. First thing I notice is that I've got a -1 raised to a power, so that means I have an alternating series, which means I can use the alternating series test, which means I've got three things that I need to test. So first I need to see if an is positive. So I just take this part. Basically, you ignore the -1. -1 just tells you that you have an alternating series. So I take this, and I want to see if it's positive, so I have to think about for n between 1 and infinity, does this give me a positive fraction? And I can split it up and think about the top. 10 raised to any power is going to be positive, and then any number raised to the 10th power, because 10 is an even number, this is also going to be positive. So I have a positive over a positive, which makes the whole fraction positive, which means an is positive, so that's true. Now, the next two, you get to decide which one of these you do first. You don't have to do them in this order. So I'm going to talk about the limit first, because that's a little bit easier to take. So the limit as n approaches infinity of 10 to the n over n to the 10. 10 over n is so much bigger than n to the 10th that we can basically ignore the bottom, and really we just have 10 to the n, which is infinity. If you don't like that method, you could do L'Hopital's rule 10 times. That's fine. Or you can graph it and look to see what happens. But the limit goes to infinity, which is not 0, which makes us sad. So that means that this series diverges. If you don't want to do the limit part, if you do the limit part and you find out that it diverges, then you don't even need to do the second part. If you want to do the second part, you have to show that we have to test to see if an, the series just an, is decreasing. You can do it algebraically, where you write it out like this. The n plus 1th term over the is less than or equal to the nth term. And you can do some algebra and rearrange that. You can also look at the graph, which looks like this. So you can see it's decreasing for a little bit, but then it starts to increase. Well, it's definitely not decreasing. So that's another way that we can tell that our function is, that it fails the alternating series test. So, it fails 2 out of the 3 conditions, it definitely diverges, but really it only has to fail 1 of the 3, and once you find one that it fails, you don't have to do any of the others. Alright, so here's one for you to try. Determine if this series converges. That's the sum from 2 to infinity of -1 raised to the n plus 1 power times 1 over the natural log of n. So figure out if that converges. Pause the video now. So here's the solution for this. The first thing I notice is that this is an alternating series because I've got -1 raised to a power. So that means I do the alternating series test. I know that an is positive because 1 over natural log of n is positive, since natural log of n is positive for everything with n is greater than 1. And the way that I know that is because natural log of 1 is 0. And if I plug in things bigger than that, I get numbers bigger than 0. If I plug in anything less than 1, then I get negative numbers. So for n is greater than 1, natural log is positive, and we're starting at 2, so that means that an is positive. The next thing I have to test is that the series is decreasing. An is decreasing. So I need to know that the n plus 1th term is less than the nth term. You can do it algebraically, you can look at the graph. I've included it algebraically here to show you what that would look like. So I started here, and then I just cross-multiplied to get natural log is less than or equal to natural log of n plus 1. Because you're taking the natural log of both sides, and because natural log is an increasing function, this is actually good enough. You could stop here and say that this is true, so that means that the series is decreasing. Or you could do this and raise each side up into a power, with e being the base, so that e and natural log cancel out, and then we get n is less than or equal to n plus 1, which is true for every n. So our first 2 conditions are true, and then our last one, we just have to see that the limit as n goes to infinity of 1 over natural log of n is equal to 0, and natural log of infinity is infinity, so we have 1 over infinity, which is equal to 0. So that means that all 3 of these are true, and our series converges. Alright, that's the end of the video. We have one more test to learn in the next video, and then those are all the tests that you need to know for the AP Calc BC exam.